we see collision is very common and important phenomena in the nature. We mostly see in the newspaper a truck hits a bike. So there is a collision between the truck and bike. Similarly, sometimes we listen truck hits the passenger. So there is a collision between the truck and passenger. Collision is also in the games. You know, when you play the carom board, the striker hits the coins. Similarly, in the cricket ball, there is a collision. Batsman hits the ball. So there is a collision between the bat and ball. Similarly, billiards ball hitting each other is also a collision. Collision is also in gases. The molecules of gases moves randomly, and when they come opposite to each other, so they collide. So there is a collision in the gases also. So in collision, there are the two quantities which are involving. One is the mass of body which is colliding. If there is a mass, then there will be the collision. Otherwise, there is no collision. And other is the velocity of the body which is going to collide. If there is a velocity in the body, only then collision will take place. If the bodies are at rest, there will no collision. For the collision to take place, one body should be in the motion or should have the velocity. So due to mass and velocity, we are having the two quantities here, and that are what we know: momentum, the product of mass and velocity, and kinetic energy. Kinetic energy, you know, half mv square, where m is the mass and v is the velocity. So depending upon the change in momentum or kinetic energy, we have defined the collision. So collision is a mutual interaction between the two bodies due to which there is a change in momentum or kinetic energy, and due to these changes we have divided the collision into three types, and first one is the elastic collision. Elastic collision. So in elastic, to study the elastic collision, let you have a ball here. So if you have a ball and drop it from this point, at this point in the ball there will be only the potential energy as the ball is at rest. When you drop it, the potential energy starts decreasing, and that is being converted into kinetic energy. When the ball going to the surface of earth and touches or hits the surface of earth, it will rebound back. Why? Because according to Newton's third law, as the ball is hitting the ground will hit the ball upward. So let us see here, this is the ball, and this ball is going and just hitting this surface. So now if ball moves up to the same height, let h. So what we are saying here, the ball from this point hits the surface, or you can say the collide with the surface, and after colliding it bounces back to the same height. Bounces back to the same height means there is no loss of kinetic energy. So the collision in which there is momentum and kinetic energy is conserved is called as the elastic collision. So how will we define the elastic collision? The collision in which both the momentum and kinetic energy is conserved is called elastic collision. And the second type of the collision is inelastic collision. In inelastic collision, what happens? Suppose you again drop a ball hits the ground, but it couldn't reach up to the height h here, but a height h dash here. So now what we are saying, why the ball is not reaching up to this height? It means there is a loss of kinetic energy. So in such collisions where momentum is conserved but kinetic energy is not conserved, such collisions are called as inelastic collision. So how can we define this? The collision in which momentum is conserved and kinetic energy is not conserved is called inelastic collision. So this is our second type of collision, that is the inelastic collision. Now the question arises where this kinetic energy lost or spent. So the loss in kinetic energy, as you know, when we drop a ball from this height, the ball will hit the ground and there will be a sound. And in some cases the ball may become hot. That can be a minimum. So means to say the loss in kinetic energy will appear as the heat and sound energy. So now we will discuss our third type of collision, that is perfectly inelastic collision, or we sometimes call it as a plastic collision. Perfectly inelastic collision. So in this collision, what happens? Suppose a body is moving and there is another body. So this body, when hitting this block during collision, what happens that this body, or you can say the bullet is the best example. When bullet is fired to the wooden block, wooden embedded in this block, and now they move together as a single object. So perfectly inelastic collision is a collision in which the bodies after collision moves as a single body with the same velocity. As bullet is embedded inside the block, so bullet and the block will move with the same velocity. The example is like if you throw mud on the ball, so mud will stick to the ball. Earlier mud and the ball were the two bodies, but after collision they become a single body. So this is our perfectly inelastic collision, or you can say the plastic collision. Plastic collision means joining of two bodies, right? So it can be called as a perfectly inelastic collision. Now we will discuss elastic collision in one dimension. Elastic collision in one dimension means in such a collision both the momentum and kinetic energy will remain conserved, and after the collision both the bodies will move along a straight line, that is in one dimension. So for that, let you have the two bodies here. Let this be the body A of mass m1, and this body is moving with initial velocity u1, and let another body of mass m2 is moving with velocity u2. Now, these bodies will collide only if the velocity or the speed of body A is greater than the speed of body B. So means bodies will collide if u1 is greater than u2, or simply suppose let u1 is greater than u2. So body will collide, and the difference of these two velocities, that is u1 minus u2, is called as the relative velocity of approach. The relative velocity of approach. So as velocity of body A is more to velocity of body B, so they will collide here like this one. So both the bodies colliding here, A, B, and mass m1, m2. So this was the position before collision, and this is the position of the bodies during collision. Now, how the bodies will separate? They collided, but how the body will separate? They will separate if the velocity of body B is larger than the velocity of body A. So, if the velocity of body B is large, let it become B2 after collision, mass m2 B. So it got separated out, and this is body A of mass m1, and let its velocity be b1. So now bodies will separate if v2 is greater than b1. v2 the final velocity of body B, and b1 the final velocity of body A. The difference of these two velocities, that is v2 minus b1, is called as relative velocity of separation. So as this is the elastic collision, right? You can say here this is the after collision. So as the collision is elastic, you know both the momentum and energy will remain conserved. So in elastic collision, momentum is conserved. So momentum is conserved mean initial momentum before collision, BC I am writing here, BC means before collision. Momentum is conserved mean initial momentum should be equal to final momentum. So initial momentum, that is m1 u1 plus m2 u2. m1 u1 plus m2 u2. This is the momentum of the system before collision, should be equal to m1 b1, that is m1 b1 plus m2 b2. Product momentum has a formula, product of mass into velocity. Let this be your equation number 1. Now just do one more things. Take m1 common here. So if you take m1 common, m1 u1, m1 b1. So what will happen? u1 minus b1, because it will come this way. As the side is changing, so sign will be minus. Now in this side m2 v2, here take u2 in this side, so it is minus u2. Let this be equation number 2. Now kinetic energy is also conserved. So kinetic energy is also conserved mean initial kinetic energy of the system should be equal to the final kinetic energy after collision. So what is kinetic energy? Half mv square. So 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square. This is the initial kinetic energy before the collision, should be equal to 1 by 2 m1 v1 square plus half m2 v2 square. So what we are seeing here, 1 by 2, 1 by 2, 1 by 2 and 1 by 2. So 1 by 2 will cancel out, and what is left? m1 u1 square plus m2 u2 square plus m1 v1 square and m2 v2 square. In the same way, take m1 common here. So what will be left? m1 u1 square minus, here it was v1 square, so it will come here and become minus, equal to 1 by 2, take m2 common here. So what is left? v2 square. This will go change side here, so it will become minus, so minus u2 square. So let this be your equation number 3 and this be your equation number 4. Now divide this equation 4 with m1. This will cancel out, m2 upon m2, this will cancel out, and now what is left? This is u1 square minus b1 square. So you can apply the formula here, a square minus b square, that is equal to a minus b, a plus b. So what we get here? A minus b, that is u1 minus b1 upon a plus b, that is u1 plus b1 upon u1 minus b1. In the same manner, you can apply the formula here, v2 minus u2, v2 plus u2 upon v2 minus u1. u2 here, u2, so cancelled out. What is left? u1 plus v1 equal to v2 plus u2. So now just rearrange this, u1, take u2 here, so what is there? u1 minus u2 equal to v2, take b1 this side, so v2 minus b1. So what is this? u1 minus u2. u1 minus u2 was a relative velocity of approach, and v2 minus v1 was a relative velocity of separation. So it means relative velocity of approach is equal to relative velocity of separation. So this is the important conclusion we draw here, and let this equation be 5. Now we will find the velocity of body A after collision and velocity of body B after collision. V1. To find V1 from the equation 5, take a value of V2. So from equation 5, V2 will be equal to u1 minus u2 and minus b1, so it will come here, become plus, so v1 plus u1 minus u2. Now let this be your equation number 6. Put this value of v2 in equation number 1. So what will be your equation number 1? So put this value in equation 1. So what will we get? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, and v2 is what? v1 plus u1 minus u2. So now we have to solve it. So for that I will have to remove it. So now m1 u1 plus m2 u2 equal to m1 v1 plus m2 v1. We have to multiply this m2 here. So m2 u1 minus m2 u2. Multiply with m2 inside the bracket. So now we have to find the v1. So first of all, it is the B1, it is also B1. So take B1 common here. We will get M1 plus M2 into B1. And here it is what? M1 U1. And here it is M2 U1. So M1 U1, when this will come in this way, it will become minus and take U1 common. So M1 minus M2 U1. Now M2 U2, and this is minus M2 U2. So minus, when come this way, it become plus. So M2 U2 plus M2 U2, that is 2M2 U2. So now from this equation you can find V1. So V1 equal to M1 minus M2 U1 plus 2M2 U2 upon M1 plus M2 multiplying here. So when this come here, this side it will divide. So M1 plus M2. So in this way we have found the velocity of body A after collision. In the same way, we can find the velocity of body V after collision. So let us find that. Now let us do here. So from equation 5, take the value of V1 from here. So V1 will be equal to V2. U1 go this side, it will become minus U1. Minus is there, so it will become plus U2. So now put this value of V1 in your equation number 1. And that was, I have written here, M1 U1, M2 U2 plus M1 B1 plus M2 V2. So put this value in equation number 1. So your equation number 1 was M1 U1 plus M2 U2 equal to M1 B1 plus M2 B2. So let us put. So now M1 U1 plus M2 U2 equal to M1 B1. So B1 has a value V2 minus U1 plus U2 and plus M2 V2. So plus M2 V2. It is V2. Now we have to find the value of V2. So what is V2 here? M1 V2 plus M2 V2. So take V2 common here. M1 plus M2 and V2 is common. Now see, this is M1 U1 here, M1 U1, and this is what? M1 and minus U1. So minus M1 U1. When this minus M1 U1 come this way, it will become 2 M1 U1. And what is left with us? We are left with M1 U2 and M2 U2. So take U2 common here. So you will left M2 minus M1 over multiply by U2 equal to this one. So from here B2 equal to M2 minus M1 U2 plus 2 M1 U1 upon M1 plus M2. So in this way we have found the value of velocity of body B after collision. So dear students, in this video we had studied about the collision, that is the hitting of two bodies, and due to which there is a change in momentum and kinetic energy. And we have also studied the types of collision, that is elastic collision, in which both the momentum and kinetic energy conserved. Inelastic collision, in which momentum is conserved but kinetic energy is not conserved. The loss in kinetic energy appears in the form of heat and sound energy. Perfectly inelastic collision, the collision in which two bodies move together after the collision, as I had taken the example when a bullet is fired to a wooden block. So it remains embedded in the wooden block and they move together. So after that, we discuss the elastic collision in one dimension. Elastic collision in one dimension means the collision in which both the momentum and kinetic energy conserved, and after collision both the bodies move along a straight line, as it is the case of one dimension. And in discussing it, we have calculated the values of final velocities of body A and V after collision, and we have also proved that relative velocity of approach is equal to relative velocity of separation. So thank you for watching. In the next video we will discuss some special cases of elastic collision in one dimension.